answer is 15 tangent 43. Okay, so notice when the variable is up top and you're dividing, you multiply to undo it. Is that okay?
Okay. Yeah, and then on the other side, would it be 15 divided by tangent 43?
Yes, yes, exactly. Okay. Okay, so that's the scenario where you're given an angle and a side. Okay, that's type 1. That's what most students like. All right. Type 2 is you're given two sides. Okay, you're given two sides. So in this case, it's the tangent of x equals 5/12. Okay, or maybe it's the sine of x equals 13.
So is this
17.
the one where you do the reverse tangent? Reverse tangent 5/12, reverse sine 13/17.
Yes. Okay. Now, what I'm asking you to do is to not make any mistakes today with this, because this is so critical. It's like, what do we need to do so that you understand that, okay, the variables inside the tangent or the sine or the cosine, you use.
Well, you explained it pretty well.
Okay.
I like how you walk through like both ends, because it messes me up, especially on the first one when I know what to do when the thing is on top, but I don't know what to do when the number I'm given is on the bottom.
Okay.
But I got it. I used to get those confused.
You're a good enough math student that like you should see that there are only three types of problems you're going to be given.
Yeah.
Variable on the top, number on the bottom, number on the top, variable on the bottom, or variable inside here. Now, this is the base case. You're in geometry, not trigonometry. When you're in trigonometry, there'll be harder problems, but for now, like this is it. So do you need to study any of this? Is any of this like, because the last thing I want to do today is to do some problems where we're going back and I'm saying, well, is it a type 1 or is it a type 2?
Because I got this.
You got it. Okay. I like that. All right. First worksheet already had the solutions in it, so I can't step in the problems. All right, here we go. The other part of this, we kind of emphasized that a lot the other day, is to draw a triangle here. So what I'm going to do here is I'm not going to fill in the triangle, but I am going to draw a triangle for this problem. I'll let you work it out. I want you to spend a full minute working it out. So don't give me your answer until 6:10 here, but let me know what you come up with. Round to one decimal place as needed for this.
Okay, all right. From the point of the ground, 50 feet on the tree, the elevation to the top is 48. Find the height of the tree. 20. So it will be opposite adjacent. So I know I will need to divide. So I will do 15 divided by tangent 48. Right. 155 less than tree. Okay. Opposite over adjacent. Ah, shoot. That's why I need to multiply. Times tangent. Opposite over. Okay.
How are you doing on this one?
I think I got it.
All right. Do you want to give me your answer here to one decimal place?
Yeah. 13.5 feet.
Okay. That feels like I haven't done anything here. I'm just going to say that. Just like thinking about it, I mean, the height of a tree, could it be 13.5 feet tall? Does seem right. The angle of elevation though is 48. You know, I'm going to just say here that I feel like that might not be the right number, But do you want me just to solve it here, or do you want to try to take another crack at it?
Wait.
So let me put some numbers in. Does this
Oh,
match?
I got it. It's 16.6.
So you're changing your answer to 16.7.
Yeah, I realized that the 15 is at the bottom, not top.
Okay. 50.
Yeah.
Okay, we're trying to find the height of the tree.
Mm-hmm.
So the tangent of 48 equals h over 50. To solve, I'm going to multiply both sides by 50.
Yeah.
Okay. Now.
Oh, 50. Sorry, I put 15. That's terrible of me. 55.5.
Okay, that sounds better. Other thing could be making sure you're in degrees, not radians. It is 55.5.
60 feet then.
55.5 feet.
Yeah.
Degrees.
Yeah, degrees.
Okay, so I think what I heard is you just 50 and 1.5. Those are common things to go between.
Yeah.
All right. All right, here we go. Here's a new problem for you to look at. Same scenario here. I'd like you to solve it and try to think about the reasonableness of your number. And that may be hard, but you want to try to envision the scenario as best you can. And I'm going to draw the same type of triangle again. Wow, that's terrible. Let's do a little better job than that. Here we go.
Okay, we're trying to find the height, it seems, this time. Okay, that's cool. So we know that the height will be opposite over hypotenuse. And so the hypotenuse will be 24. 24 on the bottom. Yeah. Okay. Okay. So then it would just be 24 times 9. 7. I have my answer.
What is your answer to one decimal place?
22.7.
That sounds pretty reasonable. What are your units here?
Feet.
Feet. Okay. So a 24-foot beam, which that's pretty long, leans against a wall, makes an angle of 71 degrees with the ground, and we want the height here again. So we're supposed to presume that the ladder is the beam. It's probably just an error here. So we're going to use relative to 7. We're going to use sine 71 equals h over 24. Does that sync up with what you have?
Yep.
And
Multiply
h
24 on both sides.
All right, very good. So I'm going to assume you can put that in the calculator correctly.
Yep.
Very good. All right, new problem here. All right. I'm going to keep drawing the same triangle. If you like a different triangle, you're welcome to modify, but
no, this is the same one I pictured in my head.
All right.
Whenever I'm trying to draw a triangle, that's the first one that comes to mind.
Great. So go ahead and work this out again. Give me your answer to one decimal place again, please.
The angle of an 5-foot tall boy casts a shadow of 5 feet long. Okay. Well, 5 foot tall. Okay, so then that will be opposite over hypotenuse, which once again gonna be sine, but oops, we gotta do opposite. Sine is 20. 5 foot tall. 5 foot. Oh, okay. Okay, almost got me there, but I have my answer.
Okay, what is your answer?
45 degrees.
That is correct. Which trig function did you use?
Opposite tangent, whatever it's called.
So you use tangent. Good. Now, is x or y the angle of elevation?
Which one? It will be x.
It is x. This is a true or false. Y is the angle of depression.
Yes. No. Actually, no. It'll be on the other side.
Yes, z is the angle of depression.
Mhm.
All right, good stuff. I've got another problem here for you to do. You're doing great. Hopefully that introduction really helped, like you said. So here's one more. If you look at before I find some more difficult ones.
Okay, 40-foot ladder, which is leaning across the 36 feet above the line. Okay, 40-foot leaning, 36. Wait, so then that will be that. All right. The angle will be 25.8 degrees.
Okay. Does that pass sort of the reasonableness test here?
Yeah.
Like does that seem reasonable based on what you kind of know as an angle? Okay, that's good. Between the ladder and the ground. Okay, are they asking for x or y in this problem?
They are asking for y.
Y. So y. Did you sine, cosine, or tangent?
I use cosine.
So cosine of y would be the adjacent over the
And then
hypotenuse.
over hypotenuse, yeah, 36 over 40. And then I use
but cosine is adjacent over hypotenuse. The adjacent is not given unless you calculate the adjacent.
Oh, I keep on forgetting which one's adjacent. It'll be sine.
Sine y equals 36 over 40.
Sine y over 36 over 40. 64 degrees. 64.1 degrees, actually.
Yeah, 64.2 degrees. Looking good there. Okay. All right. So let's just review that part. So, ka, toa. This is what a lot of students remember. There's other things that you can remember to get this down. I like to write it this way with the same letters so that I know what the ratio is. I sort of read it so, ka, toa. This is just as important as the
All right.
This is just as important as the type 1, type 2. You have to have this down. Now, you raise a good, you kind of raised like a thought, which is like, well, how do I know which is the adjacent? Okay. So here's the truth. This is always the hypotenuse.
Yeah.
Always. There's never a situation where that's not the hypotenuse. This is either the opposite or the adjacent, opposite or the adjacent. Okay. It depends on where you're at. So if you're at A, actually, let me do it differently. Color code this here. So if you're at A, this is opposite and this is adjacent. If you're at B, this is opposite, that's adjacent.
All right. Okay.
All right. I was going to do a different problem with you, but let's just do one here like this. We had some issues with this the other day. So whenever you see a shadow, shadow is not the hypotenuse. It's always the horizontal. So go ahead and work this one out and let me know what you come up with.
Okay. Why no 75 feet long? So what's the angle of elevation it's asking? Well, you see, here, I'm gonna do a little tangent. Okay, it's going to be 69.4 degrees.
Okay. So 200 feet high, 75 foot long.
4 feet long.
Are they asking you for X or Y in this problem?
They are asking me for Y.
Y. So did you use sine, cosine, or tangent?
I use tangent.
Tangent of Y equals 200 over 75. Y is the tan inverse of 200 over 75. All right. Good job on that. All right, so here's kind of this, there's a problem here I thought might be good to do. I'll give you the picture to go along with it. Person in an apartment building sites, I guess that sites the top and bottom of an office building 500 feet away. The angle of elevation for the top of the office building is 23 degrees. The angle of depression for the base of the building is 50 degrees. How tall is the office building? So they're looking for this height over here.
Mm-hmm.
Any idea how to work out this problem?
Person, okay. Well, I know the height will be 500.
The height is not 500. It's the distance away.
Oh, distance, the angle of elevation of the building is 20. So no, 23 will be the bottom one, and 50 will be the top one.
So you got to be careful here. The person is like looking out their apartment here.
Mm-hmm.
So the elevation this time is 23, and this is depression is down here 50.
Yeah, top, bottom.
Okay, and then this side of the triangle is 500. So it's almost better to draw two separate triangles here. 23 degrees and 500. And you really want what I'll call height one.
Okay, so all right, so
calculate that for us.
I know exactly what to do.
Okay.
So I'm gonna go ahead and well that right there, so that's gonna be adjacent, and so I'm gonna actually do tangent, which will be opposite over adjacent, which 500 be the bottom, and so then I'm gonna find the tangent of 23 times 500, and I'm gonna multiply that by 2.
It's not times 2 though, because the other triangle is different. It's 50 degrees.
Times. Okay, well then I'll just do it separately then.
Okay.
And I'll do the same for the other thing. I will do that, but with 50 now. But the 50 will still be adjacent, actually. Let's change it. 50 times. Okay, all right. And then take 1.
You have that answer for me?
Yeah, I'm just adding them right now. How do I copy on the Desmos calculator?
I don't know if you can, but I think it's the usual Control C, hit Enter, Control V, or right click.
Right, you got it. Oh, okay, so plus. Okay, plus the tangent. Sorry, hold on. Uh, 807.9.
All right. That's close enough. All right, good job. So try to, when you're looking at problems